welcome in our session on solving equations. Again, two main things that we're going to be going over here today. Again, starting off with those fundamentals. We're going to learn how to solve any equation. So we're going to learn the fundamentals, the basics behind that. And number two, we're really going to get into tackling multi-step equations or those more and more advanced problems. All right, we got those two things going on. So let's go ahead and dive on in with some notes here. I'm going to make these notes progressively simpler, but one thing I do need you to do is simply to go ahead and write all of this mumbo jumbo down. We got four main steps to solving equations. And so let's just go ahead and start writing these down. I'm going to go to number one, give it about 10, 20 seconds and keep moving on from there. But number one, simplify both sides of the equation. So here's the thing. What this means is basically saying, hey, give yourself an easier time by combining any like terms that you think might combine. Let me give you an easy example. So an example for number one here would be this. If I had something like this, let's say we had x plus 2 plus 5 equals 29, something like that. Everybody, quick question. Do you notice anything about the left side of the equation that we can do to make it look easier? Before we continue, just want to take a quick moment to thank you for watching this video. And all I ask is that you please like, comment, and subscribe to the channel. That way more people just like you can see these videos. But on top of that, if you're looking for more ways to practice the right way and raise your score with guidance without stressing, then I really wholly 100% recommend my ASVAB All-Access Program. The program, long story short, helps you watch, practice, and master every topic, from the word knowledge to paragraph comprehension, arithmetic reasoning, math knowledge, general science. It's there and it's designed to help you succeed with practicing the right way. So with that said, check out the link in the description to see how it all works, because you're going to have ways to learn in every way that you prefer. And you get my guidance and my support all the way until you pass. So don't hesitate. Stop feeling nervous and being anxious and letting yourself feel that way when there's a solution waiting right here for you. Check out the link in the description. That way you see how it works. And then reach out to me if you have any questions about it. Let's get back to raising our scores. Is there anything we can do on that left side? And if you're going to say add, Jose, add what? What would you say? Jamar, what would you say? Add what? Tiana says add the 2 and the 5. And Smalls, you're correct. The x is not by itself, but that wasn't the point I was trying to make quite yet. Right, the 2 and the 5 can be added together. Because everybody, think about it like this. If I were to tell you, hey, take 2 steps forward, then take 5 steps forward. I didn't have to waste my breath saying all that. I don't have to say take 2 steps forward, take 5 steps forward. Everybody, what could I say in a shorter way that's the same thing as saying plus 2 plus 5? What's the same thing? Right, plus 7 steps forward, 7 steps forward. So that's really what I mean. Simplify both sides of the equation, meaning if you see anything that could be combined or could be shortened or shorthanded, do it. And here, that's exactly this right here. Plus 2 plus 5 is just the same thing as saying plus 7. So yes or no, before I continue, yes or no, does that make a little bit of sense in terms of me saying, first step, just really browse real quick. Can you just simplify anything easy? Does that make sense? And absolutely okay if it's a no, because we got plenty of examples coming in. But the point of that first step is really just to give yourself an easier time if there's anything that you can simplify for yourself. Because I can guarantee you, a lot of you may have seen some problems like this, where it's like x plus 2 plus 7 plus x equals something like x plus 3. Something to that effect. I'm sure that you guys have seen that maybe once or twice while you practice. And if you haven't been there yet, no worries. But right there, you can give yourself a much easier time. So moving forward to number 2. And again, please go ahead and write these down, my party people. Number 2, move all parts of the equation containing the variable to one side and then the regular numbers on the other, really. What does that look like? Let me just give you a brief example here. We're not solving these equations. I'm just giving you examples of the steps. So let's suppose that we're not looking at the same example. Let's say we're looking at something slightly different here. Let's say we're looking at something slightly different, like, let's say 2x plus 3 equals, let's say 7, 18, 18. Doesn't really matter. Now, here's what I mean. We want to get everything that contains the variable. So let's say that 2x, we want to get that by itself. And if you take a look, I think you can see that there's a plus 3 right there that's kind of in the way. And the way that you're going to do that is simply by working backwards. And again, we're going to talk about that more, so don't get too frustrated yet. I'm just showing you examples of what this means. We're basically going to go from something like that to getting the 2x by itself. And again, I'm not going to show you how we got the 15. Don't worry about that. All I'm saying is step 2 is get the variable by itself. I'll show you more on the details on that as we move along. But right now, I'm just giving you a quick little preview, and then we're going to get into all of those fundamentals, all of that reasoning. I got you. Exactly, Rose. Make X the subject of the formula. Exactly. But if it's a P or a K or an L, I mean, obviously different letters, but we're going to make those letters a subject of conversation. So step number 2, again, don't worry about the mechanics just yet. Step number 2 is anything that has X or the variable, get that on one side. If it's just regular old numbers by itself, get those on the other. Yes or no? Does that make sense? Cool. Again, we're just talking about the idea. We're going to get into the mechanics and the process in a bit. I got you. We're going to get in there. Now, let's slowly move forward to number 3. Okay. Number 3, isolate the variable you're trying to solve for. And so all that means is basically get the X by itself, part 2. And here's what I mean by part 2. Notice how in something like this, you still have a 2 right there with the X, right? We still have a 2 in front of it. So as it stands, 2x equals 15. Quick question, everybody. Can that be a final answer? Can you say 2x equals 15 on the test? Not at all, right? Not at all. We got to get that X by itself. It literally has to be X equals blank, not 2x equals blank, not negative X equals blank, not potatoes and bananas X equals whatever. No, it's literally just X by itself. So again, step 3 is just like saying isolate X part 2, like really isolate X if you have to. And so let me give an example here. An example here would be like saying, hey, we have ourselves 7x equals 28. And what this looks like is like saying, hey, get rid of that 7. And in this case, the way we would do that is by dividing 7. And again, we'll get into the mechanics in a bit. But in this particular situation, we get rid of the 7 by doing opposite operations. And again, we'll talk about that in a bit to get our final answer. Right, in this case, we would have divided 2 on both sides. But again, I'll explain more on that in just a bit. But step 2 and step 3, everybody, they're pretty similar. First step, or step 2, what we're doing is we're kind of just grouping anything that has to do with X on one side, anything that has to do with anything that's not X on the other. And once you have those set up, then step 3 is basically like isolating even further. Step 2 is more so with addition and subtraction. And the step 3 is more so division, multiplication, but that doesn't apply for everything. Generally speaking, this is just saying isolate X. And these first 3 steps are pretty much what you need to know. But if you want to make sure you're building confidence, you got to know step 4. And so everybody, really quick here, for those of us, give me one moment here, but for those of us that have solved equations before, what's the one thing you typically always want to do after you're done solving, especially if you're not confident? What's something you typically want to do? Yeah, we want to plug it back in. We want to plug it back in. Absolutely. So with that, I'm going to scroll on in there. Exactly. So with that said, That's really what we have to pay attention to here. We want to plug it back in at the end if you want to check your work. So for example, if I had a problem like this and said, hey, randomly, we just solved this problem, 2x plus 3 equals, let me just give it a quick example here. Let's say 2x plus 3 equals 11. And I told you that x equals 4. If I told you that x equals 4, you can plug x back in. Just take a look. If I plugged it back in, then you can figure this out. Is it true that x equals 4? And you would see 2. Everybody, what operation is that between 2 and x? Quick question. What operation is that? Yeah, multiplication, exactly. So we would have 2 times 4, and then plus 3 equals 11. Exactly. And so from there, okay, well, we'll do the multiplication first. So we'll have 2 times 4. Everybody, 2 times 4 is what? Appreciate that, Jonathan. That's quick. Yep, that's going to be 8. Then we have 8 plus 3 equals 11. Everybody, is 8 plus 3 equal to 11? Yeah, it is. And so you see that we have 11 equals 11. So yes, everybody, yeah, this is a true statement. Yeah, x is equal to 4, and you can say that you've checked your work and you're all good. That's what that looks like. Checking your work simply means plugging it in and seeing if the equation, or again, the thing that says this side equals that side, all you're doing is making sure that it's true. That's it. That's it. So with that said, let me just review one more time. Again, this is just a very, very brief overview. We're going to get into the mechanics in a second, but the brief overview is this. First step, just see if you can clean anything up. Simplify, basically. Step number 2, anything that has your variable, put it on one side. Anything that doesn't have to do with the variable, put it on the other. Step 3, okay, cool. Once you have that, then work backwards in whatever way you need to get the variable by itself. That's your answer when it's just a variable, not negative x, not 2x, not 5x, but just x. And then the last step, again, as you're building your knowledge base up, then you want to check your work at the end by plugging it back in. So again, this is just a general overview, but yes or no, does this general overview make any sort of sense so far? Okay, good. And again, participation is key. My party people, I do have a lot of people participating today, but as always, we got to promote it. So with that, let's get into this next piece. So one thing that a lot of people have questions on is really the idea of combining like terms. So a lot of people, while they're learning this, while they're beginning to learn this, and even refreshing after a long time, a lot of people might look at something like this and say, hey, we got x plus 2 equals whatever. And some people might think that, hey, coach, you got x and then plus 2. Isn't that the same thing as 2x? And the answer to that is no. No, they are not the same. They are not the same. So the thing is, like terms, you can only combine what are called like terms. Pretty much what like terms are terms that are basically speaking the same language. And to know what I mean by that, in terms of, hey, what do you mean, same language? Terms that speak the same language are like terms are terms that have two things, the same variable and the same exponent. So let's go ahead and write this down here to show you exactly what I mean. So right here, when you're combining like terms are terms that have, again, the same variables, same exponents. So for example, let me just, again, take a nice little example, little tour here. If we have 2x and 5x, yeah, those are like terms. Absolutely. If we had something to the effect of, let's say 3x squared and 3x to the power of 3, question, are those like terms? And if you're saying yes or no, give me a reason why. All right, different exponents. I tried to trick you by putting a 3 in the front, The number in the front, that doesn't matter. That number in the front is the coefficient. That just basically tells you how many of that thing that there are. But the exponent, here's what I'm talking about. We got x squared up there, x cubed right there. Not the same exponent. We have the same variable, same letter, same x, but we don't have the same exponent. And so because of that, you can't combine these. You cannot combine those. Just want to be very clear about that. Oh yeah, those can definitely get you. It gets a lot of people, Krista, for sure. It gets a lot of people. So I just want to make sure you watch out with that. And again, once we get into the practice, I'll make sure to emphasize a little more. Obviously, just talking about notes, it's not as good as actually showing those notes in practice. But we got to start with the notes. So make sure you have that written down there, those two examples. Now, when you're combining like terms, again, the numbers in the front just basically tell you how many there are. So if you're looking at, let's say, 2x plus 5x, you're basically saying you got 2 of these x's, 5 of these x's, and if you're adding them, that'll be 7 of them. So for example, again, right over here, 2x plus 5x, that would be considered 7x. Or if you have, let's say, 10x minus 4x, that would be 6x. So again, just some brief examples of what that looks like, okay? Because again, we're going to get into this heavily today. So I do want to give you a brief refresher or overview. And again, practice, practice, practice. Now, here's a very important piece of note. And I'm going to repeat this in the next slide. But I want everybody here to make sure that they have this written down, stapled to your forehead, tattooed on your wrist. I don't care. Just don't forget this, okay? Number one, when it comes to equations, whatever you do to one side, you do to the other. If you didn't know truly what an equation is, hear the phrase or the word, equation, equal. An equation is basically saying that it's a statement of balance. It's a statement of balance, that's all it is. This side equals this side. Everybody, let's pretend that, we're looking at a scale. Let's pretend we're looking at a scale. Everybody, if we have a scale and you have weight on this side and weight on this side, and it's the same weight, it's going to be balanced. So that's technically an equation. Now, everybody, what's going to happen if I just take some weight off of this side? What's going to happen? We take some weight off, right, it'll become unbalanced very quickly. We take a little bit of weight off right here, boom, this side all of a sudden becomes heavier. And next thing you know, it tips over, right? It's no longer balanced. But everybody, quick question. What happens if we're looking at that same scale, perfectly balanced, and we take a peanut off of this one and a peanut off of this one at the same time? What happens to the scale? Assuming those peanuts weigh the same, right? Assuming those peanuts weigh the same, right? It'll stay balanced. If you take the same weight off at the same time, nothing moves. It doesn't tip over. It stays balanced. Yes or no? For everybody, is that true? Is that agreeable to you? If you have a scale that's balanced, you take away the same thing off each side at the same time, it's not going to move. It'll stay balanced. It's only when you take something off of one side and not the other, that's when you got problems. And so the same thing works when it comes to adding weight on. If you add on to one side without adding to the other, again, one side's going to get heavier. That's what an equation is. Your goal is to basically solve the equation, figure out what that little missing piece is in there, what's inside this little box on this side, without disrupting the balance. So that's why step number one is key. Whatever you do to one side, do the same to the other. That's where that comes from, because you're trying to keep the balance or equal on both sides. And so that's number one. Write that down. And that is the worst color to use on blue. Sorry, there's no contrast there at all. Let me go ahead and grab this and get possibly lime green. Much better. All right, now for that, again, that's the most important rule that you could ever hope for in terms of solving equations. Now, number two, solving equations is the art of what? For those of you that have been to my classes before, what belongs in that blank? Right, working backwards. Solving equations is the art of working backwards. Okay, solving equations is the art of working backwards. I can't stress this enough. I really can't. If you're ever stuck on solving equations, these normal general equations that you see on the ASVAB, the thing is, really what you're doing is you're doing the opposite of what's called, and you tell me if this sounds familiar, the order of operations. Does anybody here recognize that phrase? Order of operations. Of course, right? A lot of us, I'm assuming out of the 124 folks that we have in class right now, I'm assuming that 123, at least of us, recognize the order of operations, or PEMDAS, right? Please excuse my deer and salad. When I say working backwards right here, what I mean is you're working backwards from the order of operations. That's what this is. We're working backwards from the order of operations. And again, I'm going to show you plenty of examples of how this looks and how we're supposed to handle this. But before we continue, again, 2 things I need you to write down. Number 2 things. Whatever you do to one side, you can do to the other, and you should do to the other. So let me actually emphasize that. Can and should. There we go. Can and should do to the other. Again, keep the balance. And here is your regularly scheduled announcement, my party people. Remember, guys, I host a free class every single week and more classes beyond that. So make sure to check the group tutoring schedule so you know when the classes are, when you can expect to see me live so you can raise your score and get that job you want. So click there to see the schedule, and let's keep getting back to the YouTube video right over here. And then number 2, you need to know how the order of operations works, because that's how you're going to learn how to work backwards. Okay, so write these 2 things down. These are the 2 most important notes. It's the same thing that I just showed you in the previous slide, just blown up, because I really want to emphasize how important this is. Once you have this written down, type ready in the chat box, and then we're going to start getting into some examples. Starting from those basic ones, I want to keep working our way through these tougher ones. I got you. Cool. I'll give you a few more moments. Here. Water is key. I lose my voice about 4 times a class. It's even worse when I'm filming that day too, which is typically almost always. All right, cool. So let's go ahead and continue on, my party people. Let's go ahead and move forward here. Now, let's take a look at a guided warm-up here. If you feel like you're advanced and you want to just grab all 4 of these real quick, do your thing. I'm going to ramble for like 4 more seconds. 3, 2, 1. Okay, cool. So let's take a look at this first warm-up here. VV, that is correct. I got to find out where I put them. I organized the office the other day. Oh, there they are. Okay, so let's get into it here. We have k plus 6 equals 8. So here's what I mean, everybody. Let's just go ahead and go through those mechanics. Everybody, what did I say? What was that first thing, the first number 1 important rule? What was that again? Whatever you do to one side, like, can someone give me the whole phrase again? Oh, no, not the first step to solving it. I'm talking about the must-dos, the 2 must-dos that I just talked about. Right, whatever you do to one side, you do to the other, right? Whatever you do to one side, you do to the other. And then what was the other one again? Solving equations is the art of what? Working backwards. Okay, so again, I'm going to drill this into your head. I'm going to keep saying it one way or the other, goofy and serious, and everything in between to help you memorize this. We have to make sure we keep balance by doing the same thing to both sides. And number 2, the way that we know what to even do is working backwards, okay? So let's take a look at those rules again, the 4 steps. First step, like I said, was, hey, just check it out real quick. See if there's anything you can simplify. And again, what I mean by that is on the same side of the equation. So everybody, really quick, The 8's by itself over here, so there's nothing we really simplify, right? There's nothing to really do here. So we can kind of ignore that. Let's just go to the left over here and let's take a look at the k plus 6. Everybody, question, can you combine the k and the 6? No, you cannot. That is not 6k. That is simply k plus 6. You can't combine anything. Leave that alone, okay? Leave that alone. Now, let's talk about step 2. What did we say? After you check to see if there's anything that can combine, anything you can simplify, well, the next step is really to get anything that has to do with the variable or x or k in this situation, get that by itself on one side. Anything that doesn't have to do with it, like regular old numbers, like 6 and 8, get these to the other side by themselves. So this is where that whole working backwards thing comes in. Let's take a look. We get to 8 by taking some number that we don't know, and then we add 6 to it. So if we wanted to work backwards, everybody, listen to what I just said. We added 6. What's the opposite of adding 6? What's working backwards? What's backwards from adding 6? Subtract 6. And then going to that other must-have rule, like I said, whatever I do to one side, I got to do to the other. So if I want to magically get rid of that 6, again, like on the scale, if I magically want to just take 6 off of this side, well, what ends up happening is, boom, your scale's not balanced because you just did one thing to one side, not both. But if you take 6 away from both sides, technically speaking, this scale doesn't move. It's still balanced, and all you're going to have on one side is your variable. And that's why, again, it's so important to do the same thing to both sides here. We subtract 6 on both because, again, the scale stays preserved. Boom, that's gone. We wanted to see it gone. And now we have our final answer, which is k equals whatever 8 minus 6 is. I'm not good at math, guys. What's 8 minus 6? Thank you, 2. Thank you. Appreciate that. K equals 2. Now, if I'm being absolutely honest, I think we would all be very overjoyed if we knew that all the questions that had equations on them in the ASVAB look like that, right? I think all of us can look at that and say, give me that, right? I think we can all say that. But in a way, yeah, that's what it looks like on the other class that I taught, right? But it's not going to be that way. It's absolutely not going to be that way. They're going to throw some curveballs at you. They're going to throw some different questions at you. They're going to try to make you struggle. But the thing is, they're not going to make you struggle if you stick to the fundamental rules. Whatever you do to one side, do to the other. Make sure that you're working backwards to find out what the variable is. That's it. Yeah, well, you have to deal with decimals. Sure. Fractions. Sure. Those are just numbers. Negative numbers, yes, they might be there too, but it's up to you to learn that. Because notice that solving equations is not the only topic that has negative numbers or the only topic that has decimals or fractions. Every single math topic can have decimals, negatives, and fractions. So it's up to you. It's your responsibility to take the time that you need to learn how to handle those types of numbers. That way, when you do this topic, or even rate word problems, or even proportions, that whenever you see a weird looking number, that you don't freak out and give up. So if you see negatives in today's class, which I guarantee that you will, know that you're not bad at the equations. You just need to work on the fundamentals of numbers. Yes or no, does that make sense? If you feel like you're stuck at any point today because of the numbers themselves, that just means you need to go practice the basics. And again, if you're in my program, you have access to the mental math module where you can learn all about negatives, order of operations, fractions, decimals, percents, all of those key calculating and mental math strategies for those. Plenty of practice in there to make sure you're good. No excuses. Thanks, Tia. Appreciate it. I'm actually going to make a lot more improvements coming up soon. We're working on building out more study guides and blog posts for everybody. And once those are done, we're getting right back into the math boot camp. So let's take a look at number 2 here. All right. Taking a look at number 2, we have what says here 4 equals P over 11. Okay, so like I said before, first official step is just to take a quick look. Can you simplify anything? Not really. You know, there's the 4 by itself, nothing to do there. P over 11, nothing really to do there. So we can just move straight along. We want to get this by itself. We want to get that right there, that P. We want to get that by itself. Oh, it's over there, sorry. So we want to get the P by itself. Now, everybody, this is what I mean by working backwards in the order of operations. Everyone, what operation and by what number is currently happening to the P? Not what should we do? No, what do we see? What do we observe that's happening to the P right now? What is happening right now to the P? Right, we're seeing division, but by what number again? P is currently being divided by what number? Right, by 11. If you didn't know, fractions are pretty much division. So if you look at the division symbol, if you didn't know this already, this is the division symbol, right? That's a fraction, a number over a number. Fractions are division. Just really wanted to point that out in case people had a hard time kind of understanding that. But yeah, a fraction means division, P divided by 11. So if we want to get rid of this 11 right here, this annoying 11 that's in the way of us getting P by itself, we need to do the opposite operation. So we just said dividing by 11. What's the opposite of dividing by 11? Yeah, that's right. Multiplying, but be specific here, guys. Don't get lazy. Don't get lazy. Multiply by what? By what number? Come on, say it. Multiply by 11. Multiply by 11. Go ahead. I think you're still being lazy, though. Multiply by 11 where? On just the right side? On both sides, right. So let's go ahead and finish the phrase here. If you're new to this, you're going to thank me later. I promise you, you will. So go ahead and type that all out. Multiply by 11 on both sides. And if you want to say that you're annoyed, just put both sides in all caps. Right, everybody's trying to be first to the answer, but that's not what these classes are about. These classes are about understanding how you get the answer right and why, so you can repeat that success in the next problem. It's not about just getting this one right. It's about extrapolating the know-how to get the next one right. That's what this is about. So multiply by 11 on both sides. Exactly. I need some keyboard typing skills. Well, my pleasure to help you practice here. So we're going to multiply by 11 on both sides. Boom, boom. And that's what eliminates the 11. That's what gets us the P by itself. And everybody, again, I'm bad at math. Remember, I'm bad. I suck. What's 11 times 4? Appreciate that. Thank you. Thank you. Appreciate that. And we are good. Again, just a simple one-step equation, right? Just a simple one-step equation. Do the same thing to both sides, work backwards. Let's take a look at number 3. So here's the thing about something looking like this. Has anybody ever been confused by a problem looking like this? Like you're not sure what to do with that 4 because that positive is with the X. Has anyone here ever been confused at any point in their lives? Like, yo, wait, what's this? I see plus X. Does that mean that's a plus? Does that mean it's a minus? Like, what is that? Has anybody ever been confused like that? And if you're saying no, you might not be being honest, right? All right, so let's go ahead and understand this. Before, but not now. Well, you've been in my classes before, Smalls. So here we are. We have that 4 just chilling there. And here's the thing. If you just see that sitting there, it's just honestly being added there. It's honestly just being added there. If you have like a 10 plus X, that's 10 and X being added together. That's a positive 10. Here we have 4 plus X. That's just a 4 there being added with X. And so that is just a 4 chilling there, just sitting there. If you subtracted 4 on both sides, it would absolutely get eliminated. To prove a point, let me show you another way to kind of look at this to know that that is literally just a positive 4 sitting there that you can subtract. Everyone, is it true that, if I come over here, is it true that 1 plus 2 is the same as 2 plus 1? Is that true to you? All right, it absolutely is true. If you were kind of hesitant on this one and you needed a better look, hey, no worries. You can just say 17 equals x plus 4. Yes or no, does that make sense to you? If you needed to see it and guarantee that you're seeing it the right way, you could do that. You absolutely could. Because again, 1 plus 2 is the same as 2 plus 1. Absolutely the same thing. And so now we can see this a little better. Can anybody give me a complete sentence in terms of what we need to do to get this problem right? Indy, appreciate you. Right on. We're going to subtract 4 on both sides because right here it's x plus 4. To get rid of that plus 4, we subtract 4 on both sides. Gone. And so then everybody, x equals what? 13. Exactly. And that's our answer. And that is our answer right there. So before I continue to the last one here, because now we're going to be working with a negative coming up, but do we have any questions really quick before I move on? Because again, after this next one, we're going to get into two-step equations after I give you a little bit of practice. Hey, Taylor, no worries. Look, again, my objective as a teacher is to make sure that I'm being very inclusive to everybody. So that's why I make the classes 2 hours long. I used to have them only 1 hour, the free ones, but I'm like, no, let's make them 2 hours because I want to make sure that I can go through all the refreshers and the basics and also give an opportunity to continue accelerating the learning. But if I only had 1 hour, it wouldn't be enough time. So that's why I proudly made the classes 2 hours to make sure you're good. Hey, Masobi, I understand the frustration with seeing an answer before the problem is done, but remember, just focus on the reasons why. Because I can tell you what the answer is on any question. You won't learn unless I actually explain how to get there, right? So again, focus on that explanation and the reasons why. That's really what you want to focus on. It'll happen. We have over 100 people here. No worries on that, but just focus on the reasons why. So here we go. Number 4, 90 equals negative 5b. Who here would agree if I said, hey, that 5 is being subtracted, so I should add 5 to both sides? Who would agree if I said, yeah, to answer this question, I got to add 5 to both sides? The answer to that is no. Okay, the answer to that is no. Again, this is another common mistake that I can really help you avoid. So when you're looking at this, remember that when I say working backwards, what I'm really talking about is the opposite operation. One more time. When I say work backwards, what I mean is the opposite operation. Let me write that down for you here. So let me write this over here. Working backwards it means the opposite operation, okay? It means the opposite operation. So if you would, boom, right there. Let me actually, let me actually just turn that into text. 2 seconds here. So working backwards means the opposite operation. Appreciate that, Vivi. I bought the feature myself. So with that, working backwards means the opposite operation. So please, 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 for your sake, underline that, underline it, highlight it, do whatever you got to do. Working backwards means the opposite operation. Now, I'm going to go ahead and show you the example of what I'm talking about here. Whoops. Oh, I see what's going on. Give me a second there. And right there. Cool. So let's go ahead and take a look here. 90 equals negative 5b. Everyone, question, what operation is actually happening between the negative 5 and the b? What operation is actually happening that we see? Yeah, multiplication, multiplication. And just like you're watching this video for free here on YouTube, I got more free materials for you, my ASVAB party people. We've got a free practice test that comes with video solutions so you can learn from every single mistake and identify those topics that you need to crush and work on. And on top of that, you can get a free class with me on Zoom once a week. And so that's all included in my free practice test with my free class included. Click that link in this video or in the description, sign up, keep learning for free, and keep raising your score. I'm proud of you. Let's keep working hard, and let's get back to the problem. So as a reminder, if we see 3x, that's 3 times x. If I see negative 2a, that's negative 2 times a. So if you see negative 5b, that's negative 5 times b. So who wants to take a guess as to what the opposite operation is and what number we should be doing that operation by? So what's the operation and what's the number? To both sides. Dividing by what? Okay, so you got the division, right? Dividing by negative 5. Yes. Divide both sides by negative 5. Be very careful how you do that. Because here's the thing. If I divided by just 5 on both sides, I only get rid of the 5. If I divide by the negative 5, then I'm getting rid of that negative right here. If I divide by negative 5, then yes, I'll get rid of the negative as well. Because remember, everybody, a negative divided by a negative is a positive. So if you divide a negative by a negative, you will eliminate it. You will cancel it out. So just want to make sure that you remember, anything divided by itself is 1, or anything divided by itself cancels out to give you 1. So remember, the sign matters too. The sign matters. And don't forget, we got to do it to both sides. Negative 5. And let's get it done. So the first question is, everybody, what's a positive divided by a negative? Right, a negative. And if you didn't know that, again, take the time to practice working with negatives. Again, if you're in my program, you got all the practice you need. Make sure you get in there and really put in the time, because the more you practice the basics, the more you can expand and learn about these word problems that you're struggling with. So again, negative or positive divided by a negative is a negative. Then we have 5 divided into 90, which I'm happy to work out for you right here. 5 goes into 90. Let's see. 5 goes into 9 one time. Subtract the 5 and we get the 4. Then 5 goes into 40, 8 times exactly. And so we're good there. We get 18. Negative 18 equals B. And there's our answer. So just to recap here, again, the signs don't really make a difference, because it's not about the signs, it's about doing the opposite operation with the exact number, okay? Doing the opposite operation on both sides is what matters. So just because you saw a negative on the 5 does not mean you're subtracting. You're subtracting the 5b. But when we're talking about getting the b by itself, it's negative 5 multiplied by b. That's one of the main things that a lot of people miss. I'm going to say it one more time. Remember, you're trying to isolate the variable. So if there's a number attached to the variable, you need to understand the sign that's in front of it as well. Negative 5b means negative 5 times b. So you would just change the operation, same number, divide by negative 5 every single time. Yes or no? Are we starting to make a little more sense here? Because we're about to get into that two-stepper in a second here. So how are we feeling so far about these one-step equations? So that's with negatives, Kai. So when you're talking about adding and subtracting with negatives, those are the rules that you need to learn and really take the time to get into, for sure. And so again, for those of you in the program, again, we just took the first hour going through these fundamentals. We're about to start getting into 2 steps. And then tomorrow's class, we're following up on this class, starting with those 2, well, we'll do a quick refresher, but then there's 2-steppers and getting to the multi-step if we haven't already gotten into them today. And before you go, if you like what you saw and you want to raise your score with thousands of practice problems just like that, so you can lower that test anxiety, raise that confidence, go to this link right here to check out the full program. There's a video that shows you exactly how it works. but you're gonna get lessons, guided practice, worksheets, speed drills, and everything that you need to feel supported from day one all the way until you pass. Again, I'm Coach Anderson, and I'll see you soon.